Gravimetric stoichiometry. Basically, all you're doing in it is you're going from a mass of a substance A to a mass of another substance, substance B, in a balanced chemical equation. And in this equation, A and B could be reactants. One could be a reactant and the other a product, or they could even be two products. But you start with a mass and you go to another mass. So this is really important in manufacturing processes. You need to know how much of your reactants you need to mix to make your product. You don't want to have too much because that's wasting. You don't want to have enough because then you're not making enough product. So it's really crucial to figure out how much you need, and this is all going to be based on stoichiometry, the relationship, the mole ratios between your reactants and products in your chemical equation. So you would have to be given information about A. You would have to know the mass. This would have to be given to you in the question. Because you know what your substance is, you can calculate the molar mass of substance A. Because we know what substances we want to know information for, we must know the molar mass of B also. So now we've got 3 pieces of information we know. We can use these to find the piece of information that we want, which was the mass of our second substance, substance B. A and B are connected by the mole ratio. So this is your ratio of your B to your A in your balanced chemical equation. So we have to be able to calculate moles. You have to calculate moles of A because your mole ratio only works on moles. So you calculate your moles of A, use your mole ratio to change it to moles of B, then use that to change it to your mass of B. So you can find the moles of A by using your formula, mass of A divided by the molar mass of A. That gives you moles of A using your moles ratio. So you're going to multiply it by the moles ratio of moles of B to moles of A from your balanced chemical equation. That gives you moles of B, but we want mass. So if we take the moles of B, multiply it by the molar mass of B, we get mass. This is all you would do for each and every question. Calculate moles of A, the substance you know information about, convert it to moles of B, and then use the moles of B with the molar mass to find the mass of B. So we're going to do question 1 on page 227. We've got aluminum oxide can be decomposed to produce elemental aluminum and oxygen gas. This is a skeletal chemical equation. It's not balanced. You must have a balanced chemical equation in order to do stoichiometry. So we've got an odd number of oxygen and an even number of oxygen, so we're going to make both sides even. So we're going to double this, which means we need 4 aluminum and 3 oxygen. So don't forget, if you have an odd number of an element on one side and an even number on the other, you're going to multiply something by 2. And it's going to be what contains the odd number. So, odd number of oxygen, double it. Now we've got an even number. So, underneath your chemical equation, write in what you do know. We know the mass of aluminum oxide that we start with. It's 125 grams. We know the molar mass because we can calculate it. It's 101.96 grams per mole. And we want to find the mass of aluminum that's produced. And the molar mass of aluminum is 26.98 grams per mole. So we have information about aluminum oxide. We need information about aluminum, so we're going to calculate the moles of aluminum oxide. So it's mass divided by molar mass carry an extra, at least one extra significant digit because this is not our final answer. So we've got that number of moles of aluminum oxide. So the mole ratio that we need to use has to have substance A, aluminum oxide, on the bottom so that it cancels. And from our chemical equation, that number is 2. And on the top, we're going to put the substance that we want, substance B. And there's 4 moles of that. So, moles of aluminum oxide will cancel. We will be left with moles of aluminum. So now we've calculated the moles of aluminum. We want the mass of aluminum, so we only have one step more to go. So we're going to take our moles of aluminum and multiply it by our molar mass of aluminum to figure out mass of aluminum. So 2.4518 times 26.98 grams per mole. Our moles are going to cancel. We're left with grams. So 66.149 grams of aluminum. We started with 3 sig figs, so 66.1 gram of aluminum. So 125 grams of aluminum oxide will produce 66.1 gram of aluminum. So, dimensional analysis. Here we've got our balanced chemical equation. We know all of this information. We know the mass of our reactant. We know the molar mass of our reactant. We know the molar mass of our product. And we know the mole ratio of our substance B and substance A. So there's 4 moles of aluminum produced for every 2 moles of aluminum oxide reacted. Okay. So we want grams of aluminum. We want grams of aluminum. So the ratio that we start with has to have grams of aluminum in it. So we're going to start with our molar mass of aluminum. We need to get rid of our moles of aluminum. There's only one ratio that has moles of aluminum in it, and that's our mole ratio. So that comes next. And we need moles of aluminum on top because we want it to cancel. Moles of aluminum cancel. But now we've got moles of aluminum oxide, and we want to get rid of that too. So we need something that has moles of aluminum oxide in it, and that's our molar mass. So 1 mole of aluminum oxide contains 101.96 grams of aluminum oxide. So now we've got rid of moles of aluminum oxide. We only have one number left, and that's all we need. We need to get rid of grams of aluminum oxide on the bottom, and we happen to have grams of aluminum oxide, so that cancels. We have no more units other than grams of aluminum, so we're done. So in your calculator, any number on top is multiplied, any number on the bottom is divided. So we get 66.153 grams. If we rounded this off, this would be 66.2 grams of aluminum, which is only off by 0.1 gram, so it's fine. So this is how to do dimensional analysis to solve these questions. You always start with the molar mass of what you want. That's multiplied by the mole ratio. Then that is multiplied by the inverted molar mass of what you started with times the mass of what you started with. It's always going to be the same steps. But don't let the steps trip you up. Always look at your units.